Okay, now I will show you how to do a imputation method by using a mice package in R. So I will share the screen. Okay. So, uh, so this is the code to do imputation method by using mice package. So here what we are going to do is we will do multivariate uh, multivariate imputation imputation, which means we will have multiple variable. So we have like precipitation, Tmin, Tmax, Avg, wind speed, RH, wind speed, uh, and so forth. So that this is the dataset that we will use. This station one. So all the station one that have precipitation and all other variables, you arrange it properly from 1992 to 2024. So you will have precipitation, Tmin, Tmax, Tmin, TAVG, RH, solar radiation, and wind speed. So the purpose is we want to do imputation based on multiple variable, which is a multivariate imputation method, which can be done by using mice package. So in mice package, we will have a lot of method actually. If you go to this link that I show to you, so this link will go to this mice package, and you will see there is I think 24 method more. There is numeric and categorical binary order unordered type of method, but you can still do all of this. But first, before you do imputation method, you must filter which method you want to use. How the first filtration that you can do is you must filter the method and only select method that give positive rainfall only. Because if you see the imputation that give rainfall negative value, so you cannot use that method because rainfall is impossible to be negative. There is no negative rainfall. Rainfall doesn't move upward; it's only move downward. So there will always the lowest rainfall is zero rainfall. There is no such thing as negative rainfall. So if the imputation method give you negative result, then you can discard that method and then only only list down the method that give positive imputation. That is the first filtration that we do when we want to select a method for imputation and when we want to compare imputation method in R. So let's do this. Let's look at the R code that I have prepared here. You can follow this one. You use library mice. If you haven't installed mice package, you can install it by using install.packages mice. So set our working directory in the same place. And then this time we will use station data for station one, which is all the station one that has all the other variable. We have precipitation, Tmax, Tmin, TAVG, RS, solar radiation, wind speeds. All of these variable will be used as predictor of each other. So information from Tmax to wind speed will be used to input the precipitation and all other parameter will use to imputation missing data in wind speed and so forth. So all of this missing data will be imputed each other. So we arrange your data like this for station one, and another station you can do repeat the same code later on. So this is the input data. So read the data set and then only read the data 3 to 9, which means on the precipitation to wind speed here, third column until the 9 column, only read the variable data. And then you can get the summary of this just fancy information that just want to see the some summary of the statistic of your variable. And then with do use the function md pairs, this one. Okay, After that, this is only additional. We have start time and end time. Why I put this start time and end time? Because sometimes imputation method takes very long time to do. Sometimes it take hours. Sometimes it take uh, days to finish. Especially when you use hourly data, or if you use hourly data, sometimes some method will require several days to complete. So I put this start time just to record how long the processing time. Because if the processing time is too much, maybe higher more than 2 or 3 days, I will not use that method, because well, practically that method cannot be used, because it's good, the method is still good, but because of the practically in terms of processing time, it's not practical to use. So we can discard that method. But this is only additional. But I believe if we only use monthly or daily data, then imputation will take very fast. Monthly data is very fast. Daily data, maybe some method will take several hours, but still it is very fast. So you can use this start time to record the time, start the analysis, and then this is the imputation method. You have imputation many method by using mice function here. So with your data set, input data set just now, m equal to 5, method equal to norm. For example, we use norm package. So if you look at the list of the method just now, we have usually, if by default it will give you PMM, predictive mean matching. And other than that, we have metastars, sample, cut, RF, random forest, mean, norm, 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 norm bot, norm predict, and so forth. There's so many methods here, more than 30 or something like that. You can run one by one and check the result first. Check the result to filter that, make sure that the rainfall is positive. If it gives negative, then you can discard that method. For example, I show you norm method here. Norm method here. So I will run this code. So it has do the imputation and end processing time. So the processing time is about one 1 second or something like that. And then complete the this is complete the, and then it complete this just to arrange the data, and then you can view the data here, as you can see, by using norm is Bayesian linear regression. By using Bayesian linear regression, you see rainfall, it give you negative value. So this norm method is not good for imputation of rainfall. So it's not good for rainfall imputation. So you can discard this method. No, don't use norm. So now we try uh, random forest. Let's do random forest RF, because sometimes some method is can good for rainfall, like random forest from my experience. So you can run again and try to check if random forest is indeed good in terms of rainfall imputation. So processing time is about 4 seconds. And then you can view. You see, random forest give a reasonable result. It doesn't give you negative value for rainfall. So it is logical answer. So you can keep a random forest, and then you can check all the method here. Check one by one for all the method, and make sure that it give a rainfall a positive value. If negative value, you can discard that method. And then you can write the result. For example, random forest just now, you will have this. You will have this complete data set for all the variable. For all the variable. Now let's see the how does rainfall pattern looks like. This is very nice result by using random forest. For my experience, random forest is one of the best method. Other than that, we have cut, non-predict, and PMM, but still we need to compare. So the pattern look natural. So this is the next step that you can use. You can do. You must filter first which method that give a positive value for rainfall. After that, you can do imputation for all the missingness. For all the missingness, 5%. It's up to you how many missingness that you prepare. So I think that's all. You can use Discord for multivariate imputation method.